Some volume problems can become very difficult to compute if you try the disk or washer method. So in this video, we'll go over a different method to compute volumes of solids of revolution called the shell method. So I'm going to explain how to set up the integral for these types of problems. So now imagine you have this region here and you're asked to rotate it about the y-axis. So let's try to sketch the solid that results if we rotate it about the y-axis. So we rotate it around. Roughly it'll look like this. So the solid region looks fairly strange. So the idea here to compute the volume by cylindrical shells is to take a vertical cross-section through this region. So imagine, take a small interval here, take a vertical cross-section. Now imagine rotating this slice around the y-axis. The shape that results when you rotate to this little section is what's called a cylindrical shell. So let me draw it over here again so it's a little bit easier to see. Okay, so I've sketched one of these cylindrical shells over here so it's a little bit easier to see. So we need to look at the components that make up one of these shells to be able to compute the volume. Right, so this circle here has a radius. So this is the radius of the shell. A typical shell will have some height. And then this piece here is the thickness of the shell. Okay, so the idea is to compute the volume of one of these shells, and then if we integrate over the interval from A to B, then we get the volume of the whole solid. Okay, so how do I compute the volume of one of these shells? Well, the shape is a cylinder, so the surface area of the outside of the cylinder is going to be the circumference of the base times the height. So the circumference of the base is 2 pi times the radius. And then if we multiply by the height, we get the surface area of the outside. And because it's a solid, we actually want the volume, not the surface area. So we multiply by the thickness, we'll get the volume. So this is for one of these cylindrical shells. And now if we integrate from A to B, then we get the volume of the whole solid. So typically, when we use the method of shells, your integral is going to be set up in this manner, right? So you have to figure out what the radius of the shell is, the height of the shell, and the thickness. Typically, the thickness when we're computing the integral is going to be either dx or dy, depending on if you integrate over the x-axis or the y-axis. And then the radius and the height is going to be different depending on what the problem is.